Hello my dear students, so now let us discuss your test number 9. So चलो start करते हैं अपने पहले question से. So the question is, the reaction AB gives A plus B. AB is 33% dissociated at pressure of P. Then what is relation between Kp and P for this reaction? So what reaction we have, guys? AB A plus B. It is a gaseous reaction and it is 33% dissociated, right? So at equilibrium, if you start with, P, right? So 33% it is dissociated, right? So if I say I start with 1 mole, initial 1 and 0, 0. So it is 33% dissociated, means the moles at equilibrium. Let me write the moles at equilibrium. These are the initial moles. And it is 1 by 3. This is 1 by 3. Right, guys? These are the moles at equilibrium. So I have 2 by 3 moles of AB at equilibrium and 1 by 3 and 1 by 3 moles of each A and B at equilibrium. Now, to calculate Kp, what I need is partial pressure of A into partial pressure of B at equilibrium divided by partial pressure of AB at equilibrium. This is the expression of guys Kp, the equilibrium constant Kp, guys, right? This is the expression. So to calculate Kp, I need the partial pressure of AB and AB at equilibrium. तो वो कैसे आएगा हमारे पास? So you know by Dalton's law, partial pressure of AB at equilibrium is the mole fraction of AB into P total, that is P, right? So mole fraction of AB, the moles of AB divided by the total moles. Moles of AB divided by the total moles. So what I'll get is moles of AB 2 by 3. Total moles at equilibrium is 4 by 3. You add 2 by 3 plus 1 by 3 plus 1 by 3 into P, right? That means at equilibrium, the partial pressure of AB is 1 by 2 P. Got it? And similarly, using the same Dalton's law, we can calculate the partial pressure of A and the partial pressure of B at equilibrium, right? So moles of A, that is 1 by 3 divided by total moles, that is 4 by 3. So we have 1 by 4 P, and also the partial pressure of B is also 1 by 4 P. So now I have partial pressure of A, partial pressure of B, partial pressure of PAB. Simply putting these value in this relation, you will get your answer. तो बस आपको करना क्या है? PA is 1 by 4P, PB is 1 by 4P, and PAB is 1 by 2P. That you are supposed to calculate to figure out the relation. Of course, very simple now, and you'll get your final answer as P is equal to 8 Kp, right? So simple Dalton's law of partial pressure we used here, the expression of Kp we used here, that is the thing. Okay, guys. Now the question is, the equilibrium constant Kp for the reaction A gives 2B is related to the degree of dissociation of A and total pressure P. So how the equilibrium constant is related to alpha and P? Now the reaction I have is A gives 2B, right? This is how. Now if I start with 1 mole of A, this is 0. 1 minus alpha, I will say 2 alpha. These are the moles at equilibrium. Equilibrium moles. Now the mole fraction at equilibrium is moles of A divided by total moles. Total moles is 1 minus alpha plus 2 alpha, right? For B, the mole fraction at equilibrium is 2 alpha divided by 1 plus alpha. So this is the mole fraction at equilibrium. Now for Kp, again the Kp equilibrium constant Kp is equal to the partial pressure of B at equilibrium raised to power 2, that is the stoichiometric coefficient, upon the partial pressure of A. So guys, this is how we write the equilibrium constant expression. While putting the value in this expression, these values simply put, Pb you put, so Pb is mole fraction into P total. So the partial pressure of B at equilibrium is the mole fraction of B into P total, that is P, right? So let me write here, guys, the partial pressure of B at equilibrium is 2 alpha over 1 plus alpha into P. Similarly, the partial pressure of A at equilibrium is the mole fraction 1 minus alpha upon 1 plus alpha into P. So putting these values in this expression, you will get the relation between Kp and alpha and P, right? So the equilibrium constant expression, and you're supposed to write your partial pressures in terms of alpha and P. So you'll get your relation as A. Yes? You can check here, guys. Simply putting the expressions in the Kp expression. Okay. Now the question is, for reaction PCl3 plus Cl2 gives PCl5, the value of Kc at 250 degrees Celsius is 26 mole per mole per liter, the value of Kp at this reaction. So we are supposed to write the relation between Kp and Kc. Kp is equal to Kc RT delta N. Delta N is the change in gaseous moles, right? So what is delta N here? Delta N is, on product side I have 1 gaseous moles, on reactant side I have 2 gaseous moles. So change in gaseous mole is minus 1. Got it? So we need to calculate Kp. Kc is given to us, guys. Temperature should be in Kelvin. You are supposed to calculate the temperature in Kelvin. Just make sure, guys, don't commit this mistake कि टेम्परेचर आप डिग्री सेल्सियस में ही ले लें हर क्वेश्चन में. जस्ट टेक केयर दैट यू आर सपोज टू टेक योर टेम्परेचर इन केल्विन. सो 250 plus 273, so it is 523 Kelvin, right? So you have Kc value given to you, you have R, that is the gas constant. I hope you all are aware the value of gas constant 0.0821. Temperature is given to you, delta N is minus 1. Relation, putting the values, I'm sure you'll get your answer. Just be careful with the units, guys, that's it. So the answer indeed is A, right? So relation between Kp and Kc, both are equilibrium constant. One, the Kp is in terms of pressure or Kc kya hota in terms of concentration. Okay, now the question is, in exothermic equilibrium, A plus 3B gives AB3. All the reactants and products are in gaseous state. So it is a gaseous phase reaction. The formation of AB3 is favored at. तो आपको रिएक्शन को फॉरवर्ड करना है ताकि आपका AB3 फॉर्म हो. सो रिएक्शन फॉरवर्ड डायरेक्शन में एक्सोथर्मिक है. तो if you decrease the temperature, if lower the temperature, the reaction will shift towards exothermic direction. I hope आपको ली चैटलिस्ट प्रिंसिपल याद है कि कोई भी अगर आप चेंज करते हो, इक्विलिब्रियम डिस्टर्ब होता है, तो रिएक्शन उस चेंज को नलिफाई करके रीअटेन करता है इक्विलिब्रियम को. सो हमें रिएक्शन को अगर फॉरवर्ड करना है तो टेम्परेचर को कम करना पड़ेगा, सो दैट द रिएक्शन विल गो टुवर्ड्स forward direction, exothermic direction. Now let's check about the pressure. Product side we have 1 gas mole, right? And reactant side we have 4 gas moles. तो अगर मुझे रिएक्शन को फॉरवर्ड करना है तो मुझे प्रेशर को बढ़ाना पड़ेगा. इफ आई इंक्रीज द प्रेशर, द रिएक्शन विल शिफ्ट टुवर्ड्स लेसर नंबर ऑफ गैसियस मोल्स. सो प्रोडक्ट साइड गैस मोल कम है, तो बाय डिक्रीजिंग द टेम्परेचर एंड इंक्रीजिंग द प्रेशर, द रिएक्शन विल शिफ्ट फॉरवर्ड, resulting into the formation of AB3, right? So the answer we'll mark here is B. Now the question is, in a 0.25 liter tube, dissociation of 4 moles of NO takes place if the percentage dissociation is 10%. So there is a reaction, alpha is given. So alpha, what is the value of alpha here? Alpha is 10%, that means 0.1. The alpha value is 0.1. Let me write the reaction. 2NO gives N2 plus O2, right? So let us start with the initial moles. So initial moles given to us is 4. We start with 4 moles, 0 and 0. So let's say at equilibrium 4 minus 4 alpha, it will be 2 alpha, it will be 2 alpha, right? These are the equilibrium moles in terms of alpha. Got it? Kp you are supposed to calculate here. Kp, and I hope you know Kp is equal to KCRT delta N. So if you can calculate Kc here, Kc the equilibrium constant in terms of concentration, R you know temperature is also given to us, we can calculate here the relation of Kp here, right guys? Please see guys quickly. Just have a look. Yes. Done. Kp is equal to Kc RT delta N. Okay, guys, let's check. Now we have Kc. So what is the expression for Kc? Kc is the concentration of N2 into concentration of O2 at equilibrium divided by the concentration of NO at the equilibrium raised to power 2. Now the concentration, how do we calculate concentration, guys? Moles divided by volume, right? Now alpha is already given to us, that is 0.1. Alpha is 0.1. So this is 0.2 moles of N2, 0.2 moles of O2 we have equilibrium. Yes. And of course, this is 4 minus, this is 4 minus 0.4 minus 0.4. Got it, guys? Yep. That is 3.6 moles. So we have moles of NO, moles of N2O2 at equilibrium divided by volume will give us the concentration. So let me do 0.25 moles by volume is the concentration, guys, upon NO. 3.6 divided by 0.25 raised to power, right? So from here you can calculate, guys. From here you can calculate Kc. So your Kc will be here, right? The Kc, you can calculate Kc here. So that will come out to be, Kc will come out to be this, guys. Yes, you can check. Kc will come out to be 1 by 18 square. Simplified calculations here. This cancel and this 1.8, 1 by 18 raised to power 2. This is Kc. Now the interesting part is delta N for this reaction is 0 because gaseous moles on reactant side 2, product side is also 2. So जो भी value Kp की आ रही है वही Kc की होगी. Means if Kc is 1 by 18 square, then your Kp is also the same. Kp Kc equal because delta N is 0. No change in gaseous moles, right? And they were asking us Kp. So without even we know the temperature at which reaction is happening. Temperature की जरूरत ही नहीं पड़ी अपने को because delta N ही 0 है तो जो Kp की वैल्यू है वही Kc की वैल्यू है. That is 1 by 18 का square, guys. You can check here. Right? Okay, let's move ahead. The next question is what is the equilibrium expression for the reaction? So equilibrium constant का expression आपको calculate करना है. So Kc is equal to concentration, numerator में लिखते हैं हम products की, but it is a solid. So pure solid और pure liquids की concentration is taken to be unity. तो इसकी भी concentration 1 आ जाएगी और इसकी भी concentration 1 आ जाएगी. So we are just left with the expression of equilibrium constant as this. The concentration of pure solid and pure liquids are taken to be unity. याद रखना P4 and P4O10 both are solids. Pure liquid, pure solid 1. So we are left with this expression, guys, right? So the answer indeed is B. Now the question is, for the reaction in equilibrium, 2NOCl gives 2NO plus Cl2. If PCl2, P by 4, when P is the initial pressure of NOCl, then the total pressure at equilibrium. So there is this reaction given to us. 2NOCl, all gases involved in the reaction, 2NO plus Cl2, right? So the initial pressure is P here, right? But Cl2 is P by 4. So P by 4 we have Cl2 at is P by 4. That means if 1 mole of Cl2 is formed, that means 2 moles of NO is formed. Yes, that means 2 moles of NOCl is reacted. So at equilibrium we have the pressure of NOCl as P, the initial pressure minus P by 2, the pressure of NO as P by 2 and the pressure of Cl2 as P by 4, which is given in the question, right? Now the total pressure at equilibrium. So total pressure you are just supposed to calculate. Total pressure P minus 2 plus P by 2 plus P by 4, right? That is the total pressure, guys. You can see the just add on the pressure of all these gases at equilibrium. Yes. Got it? Yes, so 5p by 4 is your answer here. 5p by 4 is the total pressure. So we will mark our answer as A, A for apple. Got it? Very simple question. This is at equilibrium. Got it? Okay. Let us move to the next question. Now the question we have here is, for hypothetical reaction, the equilibrium constant K are given. A to B is K1, B to C is K2, C to D is K3. The equilibrium constant for A to D. So A to D, adding these three reactions will get A to D. So जब reactions को add करते हैं तो उनके equilibrium constant multiply हो जाते हैं. So how did we get this reaction A to D? By adding these reactions. तो अगर इन reactions को add कर रहे हो तो उससे ये reaction बढ़ रहा है, तो इसका जो equilibrium constant है वो उन सबका product होगा जो given reaction है जिनको आपने add किया है. So on adding the reaction, the equilibrium constant gets multiplied. So very simple. बहुत जल्दी होने वाला question. The answer is B. Okay. Now the question is, A3 gives 3A. In the above reaction, the initial concentration of A3 is A moles per liter. If X is the degree of dissociation of A3, the total number of moles at equilibrium is. Okay, the initial concentration is given to us. A3 gives 3A. Right? A3 gives 3A. Got it, guys? This is what it is given. Initial moles, initial concentration is A. So let me write initial. This is A. At equilibrium, X is the degree of dissociation. So A minus AX, and this is 3AX at equilibrium, right? Now the total moles at equilibrium. So total moles at equilibrium is moles of A3 plus moles of, that is A plus 2AX is the answer, right? So we'll mark our answer as D. Very simple again question. Just look at the stoichiometry of the reaction, you'll get your answer, guys. Yep. So the answer is D donkey. Okay, let us move on to the next question. Now we have this question, beautiful question. For how many of the following reaction Kp and Kc are equal? Kp Kc को बराबर करना है. इंटीजर टाइप क्वेश्चन है. तो बेटा रिलेशन क्या होता है Kp और Kc का? Kp is equal to Kc RT delta N. Delta N is the change in the gaseous moles. Reactant side और product side जो gaseous moles हैं उनका change. तो gaseous moles on product side minus gaseous moles on reactant side, right? So अगर delta N की value 0 आ जाए, मतलब reactant और product side gas के moles same हो, तो in that case आपका Kp और Kc बराबर हो जाएगा, right? तो हमें क्या देखना है? वो reaction को ढूंढना है जहां पर delta N 0 है. Reactant और product side जो gas के moles हैं वो same है. Let us quickly check out. So we have two gas moles here, two here. So yes, delta N is 0. In the second also, 2 gas moles here, 1 plus 1, 2 gas moles here. Perfect. Here the change is not 0. We have 1 mole of gas on reactant side, but 2 on product side. Yes, similarly, the change is not 0 here. This is also not 0. We have 1 gas mole here and 1 gas mole here, right? Yes, so change in gaseous moles is 0. Just gaseous moles you need to look, guys. And in this also, we have 1 gas mole here and 1 gas mole here. So here also the delta N is 0. So you are just need to figure out those reaction where delta N जितने मोल गैस के रिएक्टेंट साइड हैं उतने ही मोल गैस के प्रोडक्ट साइड हों. तो कितने रिएक्शन मिले हमें? टोटल ऐसे 4 रिएक्शन मिले जिनमें डेल्टा एन की वैल्यू 0 आ रही है. दैट मींस Kp एंड Kc विल बी इक्वल. सो विल राइट आवर आंसर एज 4, गाइस. Okay, now the next question is, the reaction N2O5 gives 2NO2 plus half O2 is started with initial pressure of N2O5 equal to 600 mm of Hg. The fraction of N2O5 decomposed when the total pressure of the system is 960 mm of Hg. Okay, so we have N2O5 gas gives 2NO2 plus half O2. This is the reaction, and the initial pressure of N2O5 is given as 600. right? That is the initial pressure of N2 as 600. So 1 mole of, as per the reaction stoichiometry, 1 mole of N2O5 dissociate to give 2 moles of NO2 and half mole of O2. So to reach the equilibrium, इसका pressure कम हुआ P, इसका बन गया 2P, and this is P by 2. Now the total pressure at equilibrium, that is 600 minus P plus 2P plus P by 2, comes out to be 960. From here you can calculate P, guys. Please check. I just added the total pressure at the equilibrium, right? So P will come out to be, yes guys, so P will come out to be 240 here. 240 mm of Hg, right? So the question is the fraction of N2O5 decompose. कितने decompose हुई है जितना pressure कम हुआ है, right? So initial pressure था 600, उसमें से कितना कम हो गया 240. So the percentage dissociation कैसे निकलेगी? 240 divided by इतना कम हो गया, initially था कितना 600. तो decomposition, right? So the decomposition that you have here is, guys, please check. Point. तो ये कितना प्रेशर कम हो गया है? प्रेशर जितना कम हुआ उतना मतलब वो डिकम्पोज किया है टू अटेन द इक्विलिब्रियम. So this divided by the initial pressure, that is the answer, guys. Yes, of course. So you'll mark your answer as O. Got it? Okay. Now the question that we have here is, for a reaction A gives B, the value of equilibrium constant at 300 Kelvin and 1 atmosphere is equal to 100. The value of delta G naught for the reaction at 300 Kelvin and 1 atmosphere is. So basically you are supposed to use the relation between delta G naught, gives you energy at standard condition, and the equilibrium constant. Very important, guys. So delta G naught is equal to minus RT Ln K, that is equilibrium constant. I hope you all are aware of this relation between delta G naught and equilibrium constant, guys. Now, minus RT, temperature is given to us 300 Kelvin. This is 2.303 log of 100. Yes, because log to the base eco, I am converting into 2.303 log of 100. Log 100 is 2. So what I'll get is minus R into 300, 2.303 into 2. That is your delta G naught. Please see, because you're supposed to write your delta G naught in terms of minus R only. So just multiply these three, you'll get your X value, right? So you'll get your X as 1380. Yep. So just multiply these, you will get your answer. Just one thing, if you know this relation by putting the value, very important relation, guys, delta G naught and equilibrium constant, you will get your answer, right? So just make sure that you know this relation and do it correctly. So the answer is minus 1380 R. That is your answer. So that's all for today, guys. Thank you so much. See you in the another session.